Like and subscribe to PAL's Fundamentals for more content like this, sources linked below. Welcome, everyone. Today, we're looking into a really interesting paper.
Yes, it's called the Biogeographic History of Iceland, the North Atlantic Land Bridge Revisited, by T. Denk and colleagues.
And our goal here is to sort of pull out the key insights, right, from geology, paleontology.
In phylogeography, yeah.
Hmm.
Looking at how species spread. It's all about that ancient land bridge that once linked North America, Greenland, Iceland, and Europe.
A bridge that really shaped plant life.
Absolutely. And, there's still a pretty lively scientific debate about when exactly that bridge stopped being a bridge.
Yeah.
When it terminated.
Okay, so let's start with the bridge itself. The North Atlantic Land Bridge, or NALB, sometimes called the Thulean route.
That's the one. And its main structure was the Greenland-Scotland Transverse Ridge, the GSTR.
Right.
And this GSTR, it wasn't just like one solid piece. It had sections. The Greenland-Iceland and then Iceland-Faeroe.
And those are deep underwater now.
Oh, yeah. Very deep. The Denmark Strait channel, for instance, is about 600 meters down today.
Right.
And it's worth noting, connections further west, like the Davis Strait between Greenland and North America,
Yeah.
probably wasn't a major route in the Neogene period. It seems to have submerged much earlier, maybe before 30 million years ago.
Gotcha. So the focus is really on that GSTR connection, but you mentioned debate about when it ended. Geologists have different ideas.
They really do. It gets tricky. Geologists often use these things called subsidence models.
Okay, tracking how land sinks over time.
Exactly. But the estimates they get, well, they vary quite a bit depending on the section.
Like how much?
Well, for the Greenland-Iceland part, you see suggestions like it submerged after 18 to 15 million years ago, but then others point closer to, say, 10 million years ago.
Huh. Big difference.
It is. And for the Iceland-Faeroe section, estimates swing from maybe 20 million years ago for the really low bits up to perhaps 10 million years ago for the higher areas.
And the last part, Faeroe-Scotland.
Traditionally, people thought that went under really early, way back in the early Cainozoic, but more recent work, like from Stoker and others in 2005, hints it might have stuck around as land or shallow shelves between 25 and 15 million years ago, maybe even later.
Wow, okay. So the geology gives us a range, maybe a fuzzy picture.
A very fuzzy picture sometimes, yes.
This is where the plants come in, right? Offering a different angle, especially the ones that couldn't just, blow across the ocean.
Precisely. That's what's so cool about the paleobotanical evidence in this Denk paper.
Yeah.
Think about plants with seeds that barely travel what we call discrete.
Right. Heavy seeds, maybe?
Or just not adapted for long distance, yeah.
Yeah.
If you find fossils of those kinds of plants in Iceland from around 15 million years ago.
It strongly suggests Iceland wasn't isolated then.
Exactly. It implies a land connection. Plants like Fagus friedrichi, a type of beech, and Tetracentron. The thinking is they probably came over from the west, from North America or Greenland.
Okay, so that's 15 million years ago. What happens later?
Well, moving forward to about 12 million years ago, you start seeing some plants that could have been bird dispersed. But you also still find things like Almonus, Caria, Corylus.
Hazel, hickory, those suggest.
They still imply a continuous connection, yeah.
Yeah.
And maybe this time, the connection was from Europe, from the east.
And then at 10 million years?
That time frame is really crucial. We find fossils of plants like Larix, larch, Sudetsuga, Douglas fir, Cyclocaria. These have seeds dispersed by wind, but not super long distances. Their presence really points strongly to a land bridge still being there.
Okay, getting harder to argue against it.
And even stronger evidence comes from an extinct plant called Trigonobolamsis. It's found in Europe, but not North America. Yet it shows up in Iceland's fossil record, from 10 million all the way down to about 3.7 million years ago.
So it must have migrated from Europe.
Seems very likely, yes. Then a bit later, around 9 to 8 million years ago, there's Fagus gusoni, another beech found only in southern Europe and Iceland. That seems to be the latest clear signal of land migration from Europe to Iceland.
But what about from the west? Any later evidence?
Yes. Around 5.5 million years ago, fossils of Quercus michuu appear. These are related to North American white oaks. It suggests migration from the west was happening possibly as late as between 7 or 6 million and 5.5 million years ago.
So after 5.5 million years ago, does the type of plant fossil change?
It does seem to. The record after that point tends to show plants that are more easily dispersed over long distances, by wind or birds. There's a pretty significant change happened around then. The continuous land bridge likely wasn't there anymore.
So the plans are suggesting the bridge, or at least functional parts of it, stayed open later than some geological models predicted.
That's certainly what this paleobotanical data indicates, yes. Connections from the east, potentially until 10 to maybe 8 million years ago, and from the west until somewhere around 6 or 5.5 million years ago.
Does modern plant genetics, the DNA studies, fit into this?
It's part of the puzzle. Sometimes the molecular studies looking at modern plant relationships and divergence times, they line up quite well with the fossils. Rhododendron is an example.
Okay.
But other times, like with Coriolis hazel, the estimated divergence times from DNA studies might differ quite a bit from the fossil story, raising more questions. It just shows how complex it is.
Different lines of evidence giving slightly different timelines.
Exactly. It highlights that we're piecing together this ancient history using different toolkits, and sometimes they don't perfectly align, which is actually fascinating in itself.
So the big takeaway from the Denk paper's plant evidence is that this North Atlantic land bridge was likely functional, allowing land-based migration significantly later than perhaps previously thought.
That seems to be the core message, yes. A later persistence, especially for these specific migration events highlighted by the fossils. Continuous links from the east, possibly until 10 to 8 million years ago, and from the west until maybe 6 to 5.5 million years ago.
It really paints a more dynamic picture, doesn't it? Seeing how these different fields, geology, paleontology, genetics, approach the same question and sort of nudge each other towards a more refined understanding.
Absolutely. Even when the timelines seem a bit conflicting, together they give us this richer, more nuanced view of how landscapes changed and how life found its way across them. Makes you think, doesn't it?
It certainly does.
How these ancient connections, now long gone, still echo in the distribution of life we see today.
Like and subscribe to Pulse Fundamentals for more content like this. Sources linked below.